Hello, everyone. Welcome back. Today, I'm going to be talking about how to factor a difference of squares. There's a very specific method that we have for factoring a difference of squares. And now you might be saying, oh, but can't we just use the methods we used before? And yes, we could. We could and we would solve it, but there's actually kind of a shortcut here so that I'm going to teach you. But it is true that we could just say, oh, well, we don't have a b value at all, so we need two things that add up to 0 and multiply to negative 36. And the only things that could add up to 0 would be something like negative 6 and positive 6. And that is indeed the answer. So actually, if I didn't show you this method, you actually could do it that other way. But differences of squares are special and they follow this special formula here. And so rather than doing this whole, thing out every single time, as soon as you see a difference of squares, you can use this shortcut. Now, first, before you take my word for it, let me explain, how do I know this is true? Other than I'm telling you at face value, this is true and believe me. Well, if we go back to our multiplying our binomials, we know that we use the FOIL rule, right? We learned that the very first day of this unit, that we do first, outer, inner, last, right? So let's do that. Let's do that with this general example. Well, first would be a times a, which is a squared. Outer would be a times b. Inner would be negative b times a, so that's minus ab. And last would be negative b times b, which is negative b squared. Oh, and look, plus ab minus ab, those cancel out, so we're just left with a squared minus b squared. So when we have a difference of squares, therefore we can always factor it this way, regardless of what those squares are. The reason I'm using a and b here is just to show this as a general rule with a general example to show that it's true for all a's and all b's, right? So we can use the same method to figure out for x squared. Right? What is the square root of x squared? Well, it's x. What is the square root of 36? It's 6. So therefore, according to the above, this is just x minus 6, x plus 6, right? Because in this case, we're treating a as x and we're treating b as 6, right? And so we're using the same equation again. We could do something similar here with x squared minus 81. We could say, oh, well, this is just x minus 9, x plus 9, according to the above equation. What about this one here? This is the same as 3x minus 2, 3x plus 2. Or what about this one here? This is the same as 7x minus 8, 7x plus 8, right? And for any of these, because it's difference of squares, because we have the plus and the minus, the outer and inner terms in every single case, just as AB minus plus AB minus AB did, they all cancel out, and that's why we don't have any middle term there. Because the middle terms technically are there, they just got canceled out, and so that's why there is none anymore. All right, so we didn't just forget about the middle terms or anything like that. They're not forgotten. It's just that they canceled out when we do the step of collecting like terms. And you can try that for any of these, and that should work for you as well. Or you can put any of these into Desmos with its original and see that, again, they're the same equation. So this is a special case of what we've done previously, which makes it a bit simpler. That said, if you do forget this method, again, you can use the other method and you will find the answer. It'll just take a bit longer, right? Because you have to figure out, oh, what are two things that multiply to this and add up to 0 and that sort of thing. It'll take more steps to kind of think about it. This is more of a shortcut for a special case of general quadratic. So I hope you enjoyed this. I hope you found this valuable, and I will see everyone next day. Bye, everyone.